All right, so we actually start trig today. We're actually going to start trig today, sine, cosine, tangent, and like I said yesterday, please let go of SOHCAHTOA. It is not your friend in this class. It may have been your friend in your high school geometry class. It is not your friend in college trig, so please let go of SOHCAHTOA. We use alpha, so some notations that we are going to use. This is alpha. Please get used to it. We're going to be using alpha. We use Greek letters, so we use for angles, we use alpha. We use theta. We may use gamma. We may use sigma. We'll be using these values for our angles. So when we're using, and beta is another one that we love. These are the Greek letters in which we see those. It means that it is an angle. So you see those Greek letters, and they are angles. Try to do the best you can on some of these Greek letters, as best you can. Let me make these a little bit better. Let me go over here and make them a little bit better. Here is beta. So that's what beta looks like. It's like a B that you start at the bottom and then come in. Sigma looks like that. I don't even know how to describe that. It's a sigma. Okay. Gamma kind of looks like a Y type thing. That's gamma. We'll use that one a lot, unfortunately. The one we do like to use is theta, because that's easy to draw. It's a circle with a bar. And the other one we like to use is alpha. So those are the ones that we typically use in trig, and those, when we see those, represents an angle. When we see this M, that means we're talking about a measurement. And when we're talking about a measurement of an angle, that is how far have we rotated. Measurement of angles is the rotation from our terminal side, our initial side, which is where we start, and our terminal side in which we end. Typically, we start here where x is positive. That is our initial side almost always in this class, unless specified otherwise. That is our initial side. Our terminal side is wherever our terminal side is, so it may be down there. And when we talk about rotation, it may just be a single rotation like this, or it may be multiple rotations to get there. Okay? So when we're talking about the measurement of the angle, it is how far we have rotated. The angle of rotation is we take 360, we divide it by, yes?
How can it be a multiple rotation like more than once?
So if it's snowing and you like to do 360s, which means that you're just spinning in one rotation, and then the 720 is 2 rotations.
Okay.
So if you're driving home and it's snowing and you don't know how to drive in the snow, you may be doing several 720s. Hopefully not ended up in the ditch. So that's what it means to do more than one rotation, right? So like when we're talking about angular and linear velocity, the wheels on our tire, if we only did one rotation, we've only got whatever the radius or circumference of our tire is gone, so we've gone nowhere really. But if we think about how many times it rotates, which we are going to figure out later in this section, if we want to know how many times it rotates from our distance of our house to our school, then it's going to have several rotations. Does that answer your question? Okay, cool. So here it is in degrees. So let's talk about degrees. This, again, is my initial side. When we do the measurements of angles, we go in counterclockwise direction. So when I go 30 degrees, I have gone 30 degrees off of my initial side, or the positive x-axis. So if I ask you for 225 degrees, that means I have gone here. Okay? I am going in the counterclockwise direction. If I am going in the clockwise direction, those would be negative angles. So positive angles are counterclockwise, negative angles are clockwise directions. Is there any questions so far? Okay. The other thing that is terribly important in our setup here is the quadrants. So in quadrant 1, quadrant 2, 3, and 4. So we have 4 quadrants, and these are extremely important because our sine and cosine values, our trig functions, whether or not it is a positive answer or a negative answer is going to be dependent on the quadrant that angle, the terminal side, lands in. Does that make sense? So you need to know where you are at all times. Is there any questions so far?
So
Yes.
the terminal angle is just where the rotation stops?
Yes, the terminal side.
Terminal side.
The terminal side is where it stops.
Okay.
Questions? Any other questions? Okay, cool. So, hopefully you all wrote down all of that stuff on the previous page. Determine the quadrant in which each angle lies. If you didn't write it down, the x-axis represents 0 degrees. It also represents 360 degrees because you have done a full rotation. Straight up, if you didn't write it down, is 90 degrees. To the left, or the negative x-axis, is 180 degrees. Straight down is 270 degrees, or the negative y. So with your partners, determine which quadrant these lie in. Where is 85 degrees? Which quadrant? Quadrant 1. So, and in here, we use the Roman numerals, 1, 2, 3, and 4. We use Roman numerals. What about negative 200? Where is that one?
Quadrant 2.
Quadrant 2. Does anyone have questions on that one? Yes?
So it's always going to be positive quadrants, it's not going to be negative.
Yeah, so the quadrants are always positive. The fact that it's negative, we're going to go backwards, we're going to go clockwise. So this is negative 90 right here, negative 180 to here, and so I'm somewhere up here because if I'm straight up again, it would be a negative 270. Does that make sense? All right. What about the 1568? I got 2 different answers here. So let's talk about how we find the quadrant. How do we find this quadrant? You pull off multiples of 360, right? So you pull off a multiple of 360, and then a second multiple of 360, and then a third multiple of 360. How many times do you have to pull off a multiple of 360? 4 times. So when you pulled off, so when you take this and you subtract 4 times 360, what did you end up with? 148 degrees. Do you all agree 148 degrees? I don't know, you all have calculators? It doesn't make a difference in terms of the quadrant, but it does make a difference later when we're asked to evaluate
So
it.
you can't just divide by 360?
That'll tell you how many rotations you're going to have, but it's not going to tell you the quadrant in which it lies.
So you subtract, it looks like you're multiplying it.
I'm subtracting off multiples. So the question is, can I just divide this by 360? Well, it's going to tell me how many times I rotate, but it's not going to tell me where I land. So this 4 is where I have multiples. I have 4 times I have pulled off 360 degrees. 4 times I've done that. So that's why the 4 is there, so I'm taking it off 4 times. If I took off a 5th one, I would have ended up with a negative number. And so for this one, what quadrant do I land in? Dos. That is all of the Spanish I know. Dos. I used it all at once. Okay, so there are special types of angles. There is an acute angle Acute angles are angles that are less than 90 degrees, greater than 0. We'll use theta, but less than 90 degrees. So acute angles are larger than 90, or larger than 0 and less than 90. You have the right angle, which is 90 degrees. We call these quadrantal angles because, quadrantal angles because they're actually on the axes. They're on the axes. Obtuse angles. These angles are bigger than 90 degrees, but less than 180 degrees. Obtuse angles. We have a straight angle, which produces a straight line, 180 degrees. We have the quadrantal angle. So an example of quadrantal angle is 180. It's the 270. It's the right angle. These are all quadrantal angles, the ones that I've circled, which means that they land on one of the axes. The last one, nope, I guess that's it. A reflex angle, yep. Didn't put that on there. The last one is the reflex angle. So a reflex angle, that is a terrible drawing, that's like, I don't even know what that is. Just a minute, let me see if I can write this a little bit better, because that was horrendous. A reflex angle. There we go. Can you all read that now? Because the other one, it kind of looked Greek, and it wasn't supposed to be. Okay, this is a reflex angle, which means that it is bigger than 180 degrees, but less than 360, and also not a quadrantal angle. All right. So on my previous example up here, where we were pulling off multiples of 360, those two angles here, the 1568 and the 128, are something called coterminal angles. Here's how we define coterminal angles. We have two angles are coterminal if their initial side and their terminal side are the same thing. They are going to be 360 degrees apart from each other. So again, coterminal angles have initial side and terminal side being the same. They are 360 degrees apart from each other. Okay? So in this example, I have got 270 degrees. If I subtracted off 360, I get negative 90. Notice they both start right here on the initial side. They both end right here on the 270 or the terminal side. These two angles are coterminal. Yes?
So is it only coterminal if they're rotating in the opposite direction?
Nope.
Do they always start in the same?
They always have to start in the same place. They always have to end in the same place.
Do they always start on the initial side, or can they start?
They all have to start in the same initial, and by tradition, especially in this class, our initial side is the positive x-axis, unless otherwise stated. Yes?
Can you go around multiple times?
Can I go around multiple times? Absolutely. Let's actually draw the picture for this one right here. So we go back up to our example, which was the 1568. So I'm going to go, starting here, I'm going to go 1 rotation, 2 rotations, 3 rotations, 4 rotations, and then I finally get to end at 1568. Okay, that is 1568. But we also know it's coterminal to 128 degrees. So there is 4 rotations where I started in the same initial side, I ended in the same terminal side. Those two angles are coterminal. They are multiples of 360 from each other.
So in
MB is one of the angles and MA is the other angle?
So M, these are measurements. So when we see, remember, when we see M, and then that's a beta. So the measurement of a beta is equal to the measurement of alpha with a multiple, that's what the K part is, a multiple of 360 degrees. K can be negative, K can be positive, but K is an integer. So my K can take on values of negative 10 if I wanted to. K could take on values of positive 1,000 if I wanted to. It is an integer value.
So when you had the one angle that was 128, how come you didn't have to add 360 to that?
So I actually was given on the 1568, that's what I was given. And I was trying to determine which quadrant it lied in. Well, I don't know where 1568 is until I start pulling off multiples of 360. And what this one did, this example right here, is we were leading ourselves into coterminals.
Okay, so that 4 represents the K in that formula.
Yes, the 4 represents the K in that formula. It was actually a negative 4 because I'm pulling off multiples of 360.
Okay.
All right? Any other questions on this coterminal? And you all wrote the formula down, yeah? Because you're going to need it in a minute. You all wrote that down? Because you're going to need it. And one of the things I discovered with my calculus class, if I go backwards and forwards when I'm doing the recording, it is really funky and it doesn't work. So if I go on to the next page, I can't come back without some kind of weird, funky recording thing. It's just bizarre. All right, any other questions? You all wrote that formula down because then you know what's going to happen in a minute. You're all going to be finding coterminal angles. So on this example, I want you to find me 2 coterminal angles that are positive and 2 coterminal angles that are negative. And to make it more interesting, I want the least one. I want the smallest positive coterminal angles, and I want the smallest negative coterminal angles. So in other words, I wouldn't take 300 and add 50K or 50 times 360. I want the smallest one, so I want the next positive coterminal angle, and then the next one, and then subtracting twice. Okay, so on the next one, I'm going to do 300. Who would give me my first 2 positives on 300? Yes, what do you have?
I have 660 and 10.
That's what happens when you don't charge your pen. You have to use your finger and it doesn't look as pretty. Well, maybe it looks better. I don't know. All right. Any questions on that? What about the negative angles? Can somebody give me the negative angles? Yes.
Negative 60 and negative 420.
So negative 60 and negative 420. So I already have, so I have 300, I subtract 360, and I get negative 60, I subtract another 360, I get 420. Last one, who would like to give me the 2 positives on this one? Yes, what'd you get for the 2 positives? 330 and 690. Again, what I'm doing is I'm adding multiples of 360. Who would like to give me the negatives on this? Thank you. What did you get for the negatives?
Negative 390 and negative 750.
Would anybody like to go over any of these? All right. On the next grouping, you need to determine whether or not they are coterminal. Determine if they are coterminal, yes or no. 60 to see if we get the other one. If I take 380, subtract 360, do I get 20? If I take 386 and add 360, do I get 8? If I take negative 120 and add multiples of 360, do I get 592? Does anyone want to go over any of those? You're just all grateful that the proof by induction's over with, right? Cool. The worst is done. All right. The next part is we're going to convert from degrees into minutes and seconds. So if you ever look at your pictures will tell you where that picture was taken unless you've taken that off of your phone. So if you're taking pictures with your phone, every picture you take has got a longitude and latitude on it. Every picture you take with your phone, unless of course you take that feature off. So if you're going to do a crime, make sure you take that off. And shut off your cell phone or leave it at home when you do a crime, because they'll ping you where you've been. So please, whatever you do, if you're going to do a crime, don't do it. But if you do, be smart about it. I watch a lot of ID channel. All right. A lot of ID channel. So when you are looking at your degrees, minutes, seconds, when you're looking at where that picture was taken, it's going to tell you the longitude and latitude into degrees, minutes, and seconds. So it's going to be degrees instead of doing degrees, so 62.132 degrees. They take that 0.132 and convert it into degrees, minutes, seconds. So that's what we are going to do. So if we are asked to convert when it's already into degrees, minutes, seconds, so if I have I want to use that pen so bad. If I have 321 degrees and 15 minutes and 31 seconds. If I am asked to convert this back into degrees, then just like when we talk about hours, how many seconds are in an hour?
3,600.
3,600, so 60 times 60. So I take the 31 and I divide it by 3,600. How many minutes are in an hour? So I take the 15 and I divide by 60. And then I'm going to add that to the 321. So somebody with a calculator do 321 plus 15 over 60 plus 31 over 3,600 and tell me what you get to 4 decimal places. Say a little bit louder.
322.26.
Another thing. What was it?
322.26.
Do you guys agree to that? Well, no. Why is it a well, no? Because I've just increased more than one that I had, right? So I have 321 to begin with. I'm not going to get 322. So there must have been an error in the calculation. So what do you get? Somebody else tell me what you all got. I'm going to start you at 321. 4 decimal places. 0.2586. It's okay. Does anyone have a confirmation on that? Okay, we got some confirmations on that. Do you understand how we do from degrees, minutes, seconds into degree decimals? Please do these two. Who would like to give me their answer for the 45 degrees, 6 minutes? Yes, what'd you get? So 45.1 degree, and what you did was you took the 6 and divided it by what? 6 divided by 60, and that's where you get the 0.1. All right? This example on B, who would like to give me their answer on B? Yes, what'd you get? 44.323. One more decimal.
322.
That's rounded. So
Yeah, the 323 was rounded.
so 3228.
Okay. I like that. It performed. I like that. That's what I'm going to say from now on. I did not solve it. I performed it. You never know, though. Maybe I didn't solve it. So, how did you do it? Tell me how you did it.
I took 44 plus 19
Okay?
plus 22 divided by 3,600.
Yep. So the 19 divided by 60, the 22 divided by 3,600. How was that? Easy peasy. Love it. Okay. Now we're going to go in the other direction. So suppose I have 16.213 degrees and I want to turn it into degrees, minutes, and seconds. The way I do that is I'm going to totally ignore the 16 for right now. I'm just going to take the 0.213 and multiply it by 60. So somebody with a calculator, take the 213 and multiply it by 60.
12.78.
So that becomes 12.78 minutes. 12.78 minutes. Now, I'm going to ignore the 12. I'm going to do the 0.78, and I'm going to multiply it by 60. When I multiply it by 60, what do I get? What is it? 46.8. And those are seconds. Here is where we round. So we round on the seconds. So we're going to take that 8 and we're going to round up, and so we get 47 seconds. So what this is equal to is 16 degrees, 12, and I wrote 21, 12 minutes, and 47 seconds. All right? So this is a two-step process. When you are going from decimal degrees into minutes and seconds, it is a two-step process. When you're going from degrees and minutes into decimal degrees, so degrees and seconds into decimal degrees, it is a one-step process. All right? So go ahead and do those two, please. Would like to give me the answer for 39 degrees, 39.25 degrees, what it is in terms of degrees, minutes, seconds. Bryson. 39 degrees, 15 minutes. Does anyone like to go over that? Did anyone get something different? Yes.
So if there's not like, since it was 0.25 times 60, it just equals 15 and there are like any decimals, so there's no second?
That is correct. If you're like, man, I really love seconds, then you're going to put in the second marks with a 0 if you're really loving it. Good question. And what about the next one? Who would like to give me the next one? No, Bryson, not you. You already did one.
Sure.
Thank you. What'd you get? -40 what? Thank you. And 10 seconds? Okay. Negative 122 degrees, 47 minutes, and 10 seconds. Yes?
You would put negatives in front of both those?
No, because this negative takes care of it. So the question is, would I put negative in front of both of the 47 and the 10? And the answer is no, because the negative is in front of the first one, and that implies it's on all of it. All right? How was that? Not too bad? Let's keep... Oh, what did happen here? Did that just undo it? No, okay, it just went in. No, we're not going home. All right, on these, what you have to do is add them or multiply them or subtract them. Now let's just talk about let's just do an example. If I have 13 degrees, 47 minutes, and 15 seconds, I'm going to add to it 26 degrees, 51 minutes, and 57 seconds. Then what I'm going to do is I'm going to start with my seconds. Okay? So I'm going to add 15 plus the 57. So 15 degrees plus the 57. So what is 15 plus the 57? 72. Is that okay to write 72 seconds? No. So what do? I pull off a 60 off of there. So I pull off a 60, and so I get 12 seconds. And I add 1 to my minutes. So now I'm going to do my minutes. I'm going to have 47 plus 51 plus that 1 that I added to it. When I add all that up, what do I get? 99. Is that okay to put 99 minutes? No. So how much am I going to pull off? So I'm going to pull off 60. What am I left with? So 39 minutes. I'm going to add 1 up there. And now I finally get to do this last one, which is 13 plus 26 plus 1 more, which gives me 40. And that is my final answer. So we have to carry on here, and you may need to borrow. So go ahead and do A, B, and C. Really quick, who has got the first answer for me? Yes, what'd you get, Casey?
16 degrees, 18 minutes, 1 second.
Any questions? Have a great day. We'll see you on Tuesday or later today. Remember, we have a study session today at 12:30. If I'm not in my office, I will post a sticky note in which classroom you can find me.